In astronomy, objects are too far away to talk about their distances in terms of meters or kilometers or miles, so astronomers came up with new units to talk about distances. The most common ones you may have heard of are light years, parsecs, and astronomical units. But what do they mean, why do we have them, and how are they used? Let's begin with the easiest one to talk about, light years. So a light year is a distance, not a unit of time as some people think, and it's simply the distance that light travels in a year in a vacuum. That's what a light year is. Light years are extremely convenient. The speed of light is constant, so the distance that light can travel in 1 year is a fixed amount. This makes it really easy to compare distances to objects that are very far apart. Light travels at 299,792,458 meters per second. So it travels very far in 1 year. 9.46 trillion kilometers a year, to be exact. The universe is so big that light years is simply a necessary quantity. It's much easier to say 1 light year instead of 9.46 trillion kilometers, especially when you're talking about thousands and millions and billions of light years. Light years are typically used anywhere from a galactic scale to a universal scale. For example, the distance to the galactic center is 26,000 light years away, and the nearest star to us is just over 4 light years away. We often have prefixes like kilo, mega, or giga before talking about distances like light years or parsecs or anything like that, but I'll get to that later. The next distance measurement I'll talk about is the astronomical unit. Again, this is another easy one to define. It's simply the distance between the Earth and the Sun. However, this distance slightly changes, so it's actually the average distance between the Earth and the Sun. The distance between the Earth and the Sun is roughly 150 million kilometers, which is actually 0.00159% of a light year. So we actually use astronomical units on a much more local scales than light years. We use them on the scale of our solar system. For example, Pluto is roughly 40 astronomical units from the Sun, and Mercury is 1/3 of an astronomical unit from the Sun. And lastly, we have parsecs. A parsec is a little bit more complicated than the other two. Simply put, it's 3.26 light years. But why the oddly specific number of 3.26? To answer that question, we need a bit of trigonometry. The parsec is defined as the distance at which an object would have a parallax of 1 arcsecond. Parallax is just the apparent shift in the position of an object when viewed from 2 different points. You can actually test this with your own eyes and your finger. Close one eye, open the other, and see your fingers shift. This is parallax. However, in the case of a parsec, the 2 points are the Earth and the Sun rather than each of your eyes. And an arcsecond is actually just an angular unit, quite common in astronomy, where it's 1/3600th of a degree. So a parsec is the distance at which the Earth-Sun distance, 1 astronomical unit, subtends an angle of 1 arcsecond. Parsecs are typically used in the same context as light years, so galactic and intergalactic distances. For example, the distance to the galactic center is 8.5 kiloparsecs, so 8,500 parsecs. And for those who've seen Star Wars, parsec was actually used incorrectly.
Fast ship. You've never heard of the Millennium Falcon? Should I have? It's the ship that made the Kessel run in less than 12 parsecs.
Kilo, mega, and giga are just prefixes for 1,000, million, and billion. Our universe is just far too big not to use these prefixes. It's much easier to say a galaxy is 66.6 megaparsecs away rather than 217,220,000 light years away, for example. So hopefully this provides clarification on what parsecs, light years, and astronomical units are. If not, ask questions in the description. Links are in the description below. And I guess I'll see you next week for another episode of me talking about astrophysics.